Okay, what we're going to do now is show you on a Raspberry Pi how to change or enlarge the standard image you're getting for the Debian Squeeze distro, which you can download from the Raspberry Pi website, which typically lands around about 2 gig, so you can fully utilize your, in this case, 16 gig SD card. So what we're going to do here is you're going to go through various steps, and you're going to see various things being entered on the screen, and I'm going to just roughly read through some of the bits. So you're going to have an FDISK here. The first thing we're going to do is to reformat the partitions on the disk, and we're going to do an fdisk -uc space /dev /mmcblk0. So we're basically doing the -uc is sectors DOS option off, device the name mmcblk0. Basically this is saying to the Raspberry Pi, do this instruction to the SD card. Now what you can see on screen here are the 3 partitions, and what we have are 3 partitions that actually you've got the FAT32 boot partition, which is partition 1, you've got a Linux partition 2, and a partition 3, which is a swap space or page file. Now the way that you've got to enlarge things is you actually have to remove partitions 2 and 3, and you can do this whilst you're actually running. So all this is on the same SD card, there's nothing fancy here, we haven't got anything or any external disks plugged in as well. This is just a Raspberry Pi with one 16 gig SD, and the very same one that we're trying to enlarge. So already now the partition 2 and partition 3 has been removed, so we've now only got the single partition. Now you need to do a little bit of maths here. The numbers that you're seeing are actually, you basically do memory addressing on an SD card, but it's treated as a disk, so you're doing this in terms of disk cylinders. So there's some maths to do, but you basically need to work out how many cylinders you have on your 16 gig SD card. You need to obviously allow the room for the single partition, and what you've got to do here is try to work out how big your second partition, the main Linux partition, can be in the middle, but still allow on the end, partition 3, the swap space. So you need to do a few numbers and enter the various numbers you worked out on your sector numbers, in effect, like I say. So you're actually doing this by cylinder addresses, and once you've done this, you're then literally going to recreate the second and third partition on the SD card. There's another stage to come where you then grow, so the FDISK will in effect set the shape that you want to use the SD card, set the shape of how you want to use the 16 gigs. But what you then need to do is to then actually grow the second partition and then recreate the swap space page file. Now this actually takes quite a bit of time, so although this is being done as I talk, what we're probably going to do is to cut away at a convenient point, so that you can actually, and we'll come back to this, so you can actually then see the final image that's grown from just about 2 gig up to the full 16 gig, and we'll come back when that's about ready. Now at the moment, some numbers are being entered for the sector positions, and that's partition 2 set, so 309.0.022.0 has been entered there. Now for the third partition, so it's already given you the sector numbers, the defaults, and entered in there of course is following on from the 309.0.022, and that will go up. So we've now got 3 partitions set up there, and what you can see there is starts and ends, again in cylinder numbers, how many blocks, etc., the ID and the system names. So this now needs committing, and what you then also need to do is to do the grow command, which hopefully we'll get to in a moment. So we synced that, which saves it in effect, so it's committed the instructions to the SD card. Now it's doing a quick reboot, and I say quick, we're doing a quick reboot now, and you can see a lot of text scroll. Here comes the Raspberry Pi logo again as it starts up again, and bear with us, and here it comes back up again. So you'll get used to a lot of this, the Raspberry Pi configuration, etc., and restarting. You're going to very much get used to and very familiar with this kind of scrolling screen as it does what it checks. It's very open book the way it does things. It reports any devices you've got plugged in, so you might keep seeing Microsoft keyboards plugged in, so it's doing normal USB device detection each time you do a power cycle. And now it's asking for the login, so again logging in, root and password in this case, and the next step for this is to grow. Oops, let's just get that correctly done. Okay, we're having a good old human keying issue here. So logging as root and the password, and now we're going to move on to the grow command. Okay, we're now ready to do the resize or grow command, and I'm going to just explain what that is. And it's FDISK RESIZE2FS/MMCBLK0. So we're now telling the Raspberry Pi to do this, and we're going to do it with ampersand at the end to do it in the background. So whack this, get this going. It's now resizing partition 2, so it's the P2 area we're doing, partition 2. And what we will now do is quickly show you with the df command. The cylinders should now be increasing on P2 as this is being grown, and you can see the numbers increasing on partition 2 as we go. Now obviously this is step by step, so we're already up to 2.3 gig, 2.4 gig, and I'm going to just give it another 5-10 seconds, and we're going to do it once more, and then what we're going to do is come back to it when it's fully sized. It's 2.5 gig. Okay, and now we've got to the point where the first partition 2 that we've just grown is now utilising not all of the 16 gig, because obviously we've got partition 1 taking a little bit of space, and we've still got space left for partition 3, but we're now up to 15 plus gig, and the next step is to sort out the swap file, the swap space area, or the page file space area on partition 3. So although it's already on the device, that was set with the FDISK earlier, we need to do the resize FS command on this as well, and we're going to have to go through the same sequence that we did earlier, and this time for the third partition. So what I'm going to do is to probably stop the film whilst we're doing the reboot this time, so you don't have to sit through that, and we'll come back quite quickly. This won't take so long because it's a much smaller partition. And is pretty much the final stage here. So we're now getting to the point where we're doing the reboot. Okay, and I'll come back in a minute and I'll show you that all 3 partitions are set. Okay, so we've restarted again now, and what we now need to do is to ask the Raspberry Pi to make the new swap space in this third partition. So we're doing an mk swap /dev/mmcblk0p3, the third partition again, and just loading this in the vi editor. Slight correction being done here, like that, and now there's another reboot, so I'm going to come back again. We're nearly done. Okay, so that reboot's now complete, and at the very bottom, the last line where the flashing cursor is, it's saying it's activating swap, and job's done. Okay, so it's now just completing, so you're just seeing the final part there. That pause you'll see, so don't worry if you're sitting there waiting. In total this has probably taken let's say less than 15 minutes, so obviously that doesn't include the time it takes to download from the Raspberry Pi website on your PC or Macintosh, etc., to create the initial distro package that in this case the Debian squeeze distro package. That was the original image that we started with. So ignoring that first 2 gig download and writing to an SD card, it's about a 15-minute job on a Raspberry Pi with all the reboots, etc., and the FDISK and the resize commands, etc., etc. So we're now pretty much there, and it's up and going. So you've now got your 3 partitions all set. You've now got full use of your 16 gig, and it does seem a little bit odd that you grow using the same memory space, but it's treated as a disk whilst you're using the same SD card, but it absolutely works. So absolutely good job. You don't need, like I say, anything extra. You don't need any additional USB devices, anything fancy on your network, or an external drive. This all works and runs using the first partition whilst you grow the second and recreate the swap file in the third. Okay, job done. Excellent.